Hello class. Assuming that you have obtained and unpacked the lines lab, I'm going to show you how to compile, assemble, and link the quadratic equation solver program, which is the demo program from the Carter book. So this isn't going to go into how that program works, but just the mechanics of how to compile and run it and what's happening on Linux. So I will put up some text in a moment, but first let's just compile and run it. So this means run the file, the indicated file in the current directory. And the indicated file is a script called quadasm, which will assemble. And that just did it. And now I can run the file in the current directory called quad, which was the output of quadasm. You just have to know that. Didn't tell you. And it's going to solve a quadratic equation. So let's try x squared minus 2 equals 0. It should give us plus or minus the square root of 2, right? So 1x squared plus 0x minus 2, and there we have plus or minus the square root of 2, right? So great. What are we actually doing here? Well, let's take a quick look at inside that compile and assemble script. And that's how we run it. And this is what it does from the Carter book. And here are the commands that are actually in there, and we'll just see those right now. Okay, so the first command was a GCC. GCC, if you haven't used it, is the GNOME C compiler. And the idea is that the driver program, the main program for that quad program that we just ran, is written in C, not in assembler. And it does the I/O to prompt you, and it did that business of saying enter A, B, and C, and then reading and interpreting the results. And then when it got done, it called a subroutine called quadratic. And the subroutine called quadratic is inside a file called quad-a.asm. So that was our main program, calling a subroutine inside of our assembler program. That's a different file. So what's going to have to happen is a little bit different than what happens sometimes where you just hit, compile and run, because we need to have several steps here. One step is to compile the C program. Another step is that's going to be compile the C program, and that's going to produce something called an object file, which normally you might not see because you normally go directly from object file to executable program. But we need to make an object file explicitly because we're going to assemble that subroutine, which is in our quad A, and produce another object file. And now we have two object files. One of them is the main program, which calls the subroutine in the other file in a different language. So we produce two object files and link those two files together to make the executable, and that's the third step. The GNOME C compiler also links files. So typically you would do the compile and link all in one step, but if you are mixing two languages or have a bunch of different files, you might want to do those separately. So the switches here, the command line switches, minus C means compile only, minus M32 means we're doing this for the x86 architecture as opposed to the 64-bit architecture. And the default output file is going to be .o. If we started with quaddriver.c, it'll make .o object file. Then we're going to NSM is the assembler that we're using. There are several assemblers popular. And That's our input file. It's going to make quad-a.o output file, object file. Minus f_elf is going to say which one of several object file formats it could be in, and the -g-f_dwarf is going to say to include debugging information. We're not using the debugger in this lab, but the debugging information is in there. And then finally, this is GCC which is going to link. Again, it's for 32-bit. And here it says the output file name is going to be quad. And you'll notice there's our two object files input. And also this is ASMIO is a file of subroutines for I/O that you can call from assembler. They're written in C. So you can call those from assembler, and this ASM.io file is included with the Carter book. So that's what's happening inside these commands here, and I'll illustrate this again. We did the quad assembled it, and produced. There's our object files, which were produced just now. Excuse me. So you can see the timestamp on these files is the same as the timestamp here. And now we can run it. And let's just do x squared plus 0, 0x minus 4. And those are the two roots. And we're done.